funny. Okay. Hello guys. I hope you've missed my face. This is a video on introducing Learning Target 9, 10, and 11. There is another video that you will find going through the example problems from the notes on Learning Target 9, 10, and 11. Okay. Sorry, we're adjusting the camera. Yep, so you can see everything. But just to intro the unit on a little bit about volume, we're going to be using all of these shapes. First, we're going to be starting with what we call shapes. The names can get a little bit tricky between pyramids, prisms, rectangles, triangles. There's a lot of different options. So for first, we can look at, okay, we look at, there's something called prisms, which we see this is a prism because there are two bases here, okay? See, base here, base here. Where if we compare it to something like this, there's only one base there, right? So anything that has two bases we call a prism. Anything that only has one base and comes up to a point like this, we call a pyramid. So prism, pyramid. How else we name these kinds of shapes is what shape is their base. So this has two bases and they are square. So this would be called a square prism because the base is a square and it has two of those parallel bases. This is a pyramid where its base is triangular, so we call this a triangular pyramid. There's only one base and it is a triangle, so it is a triangular pyramid coming to a point. This, take a guess. Pyramid or prism in your head? Pyramid, right? Because there's only one base and it comes to a point like this. What kind of pyramid would this be? Square, exactly, because the base is square. I feel like I'm on Dora right now. So, what would this be? Yeah, exactly, this is a cube. This is kind of analogous to a prism because there are two bases here that are parallel, but because it is rounded, we cannot call it a prism. This is a cylinder, which I'm sure you guys know. But it's kind of analogous to a prism, where this is more analogous to a pyramid because there's one base and it comes to a point, but we call this a cone. We don't call it a pyramid. So triangular pyramid, triangle base, comes to a point. Square prism, square base, parallel bases. Now if we look at these two shapes, we can see here they have the same base shape. So this is kind of like this prism's counter pyramid, right? So we have the same base shape, they're about the same height. So how do you think their volumes compare? If this is the area of the base, the formula for the volume is the area of the base times the height. What do you think this is? How does it relate? How many of these would fit into here? Take a guess. Let's test it out. We have this red rice, and I'm going to see how many times we can fill up this square pyramid to fit inside of this cube. So let's see. Oh, I should keep it in this so I don't get this. Okay, so we have one pyramid. I am terrible at this. Okay, so what does that look like? Less than a half, maybe a third, maybe a fourth. Let's keep going. Fill it up again. Okay, so that's more than a half. Let's fill it up one more time. Yeah, so we filled up this pyramid 3 times to fill the volume of this cube. And if you look at your notes or on the internet for volume formula of pyramids, it's 1/3 base times the area of the base times the height, where this is the area of the base times the height, just the area of the base times the height. When we take a pyramid, It's 1/3 of the base times the height. And we just showed that because we can fill this up 3 times to get the whole volume of this. And that is also true for cones and cylinders. This is the area of the base times the height, pi r squared times the height. This is 1/3 pi r squared times the height. Where also, really quick, when we're talking about height, there's 2 different kinds of heights when we're discussing pyramids. There's slant height, which is the height of one face of the pyramid, right? That's slanted when we're looking head on. But the height we are worried about when we say base times height, just like in a triangle, it needs to be perpendicular to the base. So it's going to be like this, right? That's the height we use to calculate area, not the slant height. And if you go on to the next video, we will work through the example problem, a couple example problems in your notes, and then you guys have a worksheet that you can work through for some extra